So we're on 3-2, page 124, and go ahead and start your notes. Again, 3-2, solving equations by adding or subtracting.
When you say it's your work, like I need to write out 5 plus 9 equals 4, and then 5 plus 9 equals 4.
First of all,
5 plus 9. Sorry.
that's okay.
Yeah.
Show the work. That'll save you a lot of trouble. That's okay. That's okay. It happens.
I meant to say 4 plus 5.
That's okay. That's okay. Shh. Quiet, quiet, quiet. Listen, I'm going to show you what I mean up here. And it's not like really detailed. You're not doing an algebra mat. You're not doing a number line. It's just very basic steps to show me you know what to do on these problems, because this whole chapter is really dealing with integers. And when I'm in Algebra 1 already, they're taking a quiz. Oh, and I'll tell you about this. They're taking a quiz today, and it's with fractions and decimals, and that throws people off. Same rules, but it throws people off because we don't show our work. So make sure you do it. Okay, go ahead and write this equation here. X plus, let me make sure I get the right one here. X plus, 10 equals 14. Okay, very simple equation. It wants you to solve, which means what? What does it mean by solving? Anybody? Yes, ma'am?
Finding what?
Yeah, find what that variable is. I want to know what that value is. And some of you are like, Mr. A, I already know what it is. Well, congratulations. But we want to solve it algebraically because problems get more difficult than this. And I'm just telling you right now, they get very, very complex. Okay, so here I have an equation because I have an equal sign. Do you guys know what an equation is? What is an equation? I mean, it has an equal sign, but what does it mean? Like, what does this statement here mean? It's really a sentence. This is a deep question here. You know what it means? It means that two sides are balanced out. So I need some help here. I'm going to call on people. I need to call on two people here. Can I have Jensen and Jack up here? Can you guys come on up? You guys are my first volunteers. Okay, Jensen, you can stand right here. Jack, you can stand right there. Okay, now this is for illustration purposes, okay? We're going to assume that these two gentlemen weigh the exact same. And I am a scale. So how should I look if they truly weigh the same? Should I be like this, or something in between that? I should be balanced, okay? So I'll try to be as balanced as possible. I'll try to get you on there, Jensen. There you go. So I'm balanced right now. Max, can you do me a big favor? Can you close up your book and give it to Jensen? Okay, so what should happen as Jensen gets that book to the scale? It's to start leaning this way, right? It's a little heavier on this side. But Sophie, if you could do me a big favor and give Jack the book, what happens? We even out, right? This is one of the principles of equalities that we're going to look at. I'm going to write it down. When they were without the books, were they balanced? Yes. When I added the same weight to both sides, what happened to my balance or my scale? It stayed balanced, right? It shouldn't be like this because I added the same thing to both sides. Okay? Max, can you do me a favor? Can you take the book away from Jensen? So what happens to my scale?
It goes that way.
Whoop. So how do I balance this out? I take the same thing from him. And now we're balanced out. Thank you very much, boys. You were great weights. Okay, and that's what we're going to get to when we talk about equations. We got to keep them balanced. So if you do this to that scale, if you take away or add from only one side, you're either going to get this or this, but you're not going to get a balanced scale. And we need to keep it balanced. So, does anyone happen to know what I should add or take away to get x by itself, but to keep it balanced? So how am I going to do that? Right now it's balanced, okay? It's very balanced. and I want to do something to both sides without tipping the scales in one way or the other. Elizabeth?
You can subtract 14 minus 10 equals x.
Okay, one thing you can, say that again?
14 minus 10 equals x.
Okay, I'm going to go with this, Elizabeth. Let's say you want to take away 14 from both sides. Can you do that? Can you guys do that? Is that allowed, do you think? Can you take away 14 from both sides?
No.
Yes, you can. You really can. You can take away 14. Oops, 14. You're going to be left with x minus 4 equals 0. So did that give me what x is?
Yes.
It didn't really give you what x is. Yeah, that's one way you could do it. I'm thinking you're going to have to subtract something from both sides to keep it balanced and to get x all by itself. John?
If you subtract 10 from both sides?
Okay, write this down, guys. Subtract 10 from both sides. Subtract 10 from both sides. So if you had a balanced scale, you took 10 away from here and 10 away from here. Do you keep it balanced? Yes. But why 10? Well, let's see what happens. What's x plus 10 minus 10?
0.
Ready?
No.
X plus 10 minus 10. X. Because what happens with the x and the negative x? What happens to the 10 and the negative 10? They cancel each other out. So really, this is what happens. They get dropped out. So what's left on the left side? Just an x. What's left on the right side? 4. Oh, is x really equal to 4?
Yes.
Positively, yes.
Are you sure about that?
Yes.
All of these problems that you do can be checked by you without even looking at the back of the book. Is 4 plus 10 equal to 14?
Yes.
Okay, that's the work I want to see. And you're like, oh my. Like, no, just add or subtract the same thing from both sides. Okay, so that's one example here. Why did I subtract 10? I mean, why didn't I just add 10? Or why didn't I take away 20? Or subtract 15? Do you know the reason why?
Because you're adding 10, you have to do the opposite.
Nailed it, Tristan. All right, ready? Let's go back to this problem. And I know I hope everyone can get it in your mind, but we want to start solving these algebraically. Okay, the way to solve for x is to first look at x. So you guys see where x is? So far, so good? Not too bad? Okay, what's going on with x on this side of the equation? It's being added with 10, right? What undoes addition of 10? Subtraction of 10, right? So if I subtract 10 from both sides, which I'm allowed to do, what happens to these two values? They get canceled out. And what's left on the left side? Sorry, on the left side, yep, x. And then what's left on the right side? That's what you're going to be doing in this lesson, okay? You're going to be using inverse operations. So ready, guys? Mackenzie, what operation undoes addition? Subtraction. Emma Grace, what operation undoes subtraction? Addition. What are those two operations called together? They're called the... Okay, raise your hand. John?
Inverse operations.
Inverse operations. And what's the title of our lesson, by the way? Solving equations with or by adding or subtracting, because they're inverse operations. We're going to do that. Okay, so let's go ahead and look at two properties after we look at this first example. Look at example number 1.
Can you add negative 10?
Yes, very good. You can. And we're going to look at how to phrase that differently if we want. So example number 1, r plus 56 equals negative 5. Okay, is this an equation? Yes. Does that mean it has to be balanced? If it's a true equation, it has to be balanced. You can add or subtract something from both sides as long as you do it from both sides and still keep it balanced. So, look at r. What's happening to r on that left side? What's happening to r? Somebody raise your hand. Tell me what's happening to it. Josie, I see that hand. What's happening to r? right? It's being added with 56. You guys agree with that?
Yes.
What undoes addition of 56? What undoes the addition of 56? Braden? Subtraction of 56. So what I'm going to do is I'm going to subtract 56 from both sides. Okay? And I'm doing it in this vertical format. I think your book does it more horizontal. That's okay, but it gets really confusing when you get longer problems, more complicated. All right. Did I subtract the same thing for both sides?
Yes.
Am I allowed to do that?
Yes.
Yes, I'm allowed to take away the same quantity from both sides, keep it balanced. Okay, does anyone know, listen to the question carefully, what r plus 56 minus 56 is? Yes, ma'am? Bella?
R.
Equals r, that's nice. So right now, r is by itself. That is a main goal of algebra. Get the variable by itself. But this is where it gets tough. What's negative 5 minus 56? Negative 5. That sounds super familiar. Didn't we just do... Wasn't that just on... Isn't Mr. A going to grade? What was this just on? We were dealing with chapter 2, adding, subtracting, multiplying, dividing, integers. So what's negative 5 minus 56? I don't get that. That's just like, what's going on? Elizabeth.
It's negative 61.
Negative 61? How many of you agree? Okay, I'm like, maybe. Does my friend agree? Yes, I agree now. Okay, this is how it works. This right here is negative 5 minus 56. Isn't it hard to subtract from a negative already, some of you in your minds? Can you make this an addition problem? Can anyone make it an addition problem? See if you can do it. Yes, Sydney.
Negative 5 plus negative.
Okay, are both of these the same thing? Yeah. You may like it this way. Great. You may like it that way. Fine. Both of them should get me negative 61. Yeah, there you go. Because what's a negative plus another negative?
Positive.
It's more negative, right? So negative 61. Do you guys see how that works? Okay, run down here. Ready? Why, and I'll call on somebody here. Why did I subtract 56 from both sides? Caroline, why did I subtract 56 from both sides? Okay, so I wanted to negate this or undo this, so I subtracted. Good. What's another way of saying negative 5 minus 56? Timothy. No problem. What's another way of saying negative 5 minus 56? It's a tough question there. If only I had the answer key to that.
Well, I know another way.
Okay, that's okay.
I only know one way.
That's okay. Shh. All right. Marissa, what's another way of saying negative 5 minus 56?
Negative 5 plus negative.
It's right here. Negative 5 plus negative 56. That's okay. It's all right.
I mean, I know you wanted me to say that. That's the only way I knew how to do it.
Gotcha. Okay. So listen, when you're looking at this, you should be thinking of that whether you write it down or not. That's what you're thinking to get. So good. I'm glad you understand it. Example number 2. Example number 2. This gets a little tougher here. Example 2. This is where it gets a little bit tough, so please listen up. Y minus 9 equals negative 17. Y minus 9 equals negative 17? Okay. All right, I'm looking at this problem thinking, all right, it's balanced. I see the variable. What's happening to it? How do I undo it? So I'll ask Sophie, what is happening to y?
It's being subtracted by 9.
Okay, it's being subtracted by 9. What will undo that subtraction by 9?
The inverse operation, which is addition.
So what do I do to both sides of this equation?
Add 9 to both 9 and 17.
Okay, yeah, exactly. Negative 17, good.
Cancel the 9 and would cancel out, and it would just get y by itself. And that would equal negative 8, or just 8. Negative 8. Because different sides subtract. And
I don't know about that. That's tricky, isn't it? Some of you are saying maybe it's negative. Wait, I thought it is positive. No, negative 8. No, positive 8. Which one is it? Okay,
Negative.
this is what you do. You get your answer whether you got positive or negative, and then just do this. If you want to know if your answer is correct or not, and it's an even problem, you can't even check. What's negative 8, which we say is y, minus 9? So that has to be it. Would 8 minus 9 equal negative 17?
Yes.
No. 8.
No.
Would 8 minus 9? Nope. It has to be negative. That's my answer. Can you check all these? Absolutely. Just check it. You can do it mentally. Is this true? Check. Is it not true? Uh-oh. Do something else. All right. Let me have you do a couple practice problems here. On page 127, I want you to do number 7. On page 127 at the very top, number 7, please. And I'm going to pick, I shouldn't say that. I'm going to call on one of you to tell me exactly what I had to think and do on number 7. And again, it's at the very top on page 127, number 7. I need to see work. I need to see a step. Just one. It's just one step. Do something to both sides, and then you figure it out. Blah equals blah. Okay. Let's see. Who's the lucky volunteer?
Me.
Me as in Jensen. I'll pick this time. One more. Jensen, what do you do? What do you think? What's going on in this one?
So you do the same thing that we've done. It's y equals negative 25.
Give me some more. What's the variable again?
W, sorry.
W. But how did I get negative 25? I mean, I get that's the answer. Yeah, that fits. But how did I get that?
The negative 8 minus 8 and negative 8.
On
17. Negative 17. Both sides.
both sides. Got to keep it balanced. Okay? What happens to these two guys?
Cancel each other.
Canceled out. I'm left with what on the left side? W. What's on the right side? Negative 25. W equals negative 25. Does that really work? Well, what's negative 25 plus 8?
Negative 17.
It's negative 17. That's the only number that works. There are no other numbers. How many of you got negative 25 equals W, or W equals negative 25? Okay? All right, one more for you to practice, and then I don't know if I should I give you this one?
Yes. Yeah. Challenge.
Give us the
Challenge.
hardest one on the paper.
No, not yet. I'll get to that later. Yes, ma'am. Question?
I got the answer right, but I was asking, since you're subtracting on both sides, why wouldn't you turn negative 8?
This one right here or this one?
This one.
The on the right? Okay, this cancel out. I could change it to a not positive 8, but this is negative 17 minus 8, or I can think of it as negative 17 plus negative 8.
Okay.
Either one is okay. Both of them get me negative 25. So you can think of it either way. Okay, I want you to try this out. It is going to be tougher. Some of you are going to get it right. Some of you are not. Number 8. This is a good question to go through because you're going to see it again. This is tough, guys. Error. Do you have a question or the answer? Okay. Hold on to the answer. I'll give you a few more moments. Answer or question?
Is.
Okay, hold on that. Yep.
So, could you, do it, could you flip it around and still get the exact same answer? Would that be okay if we did that on homework?
If you flipped it around properly, yes.
Okay.
So we'll go over that if you guys need it. Okay. Who wants to share their answer here? Rosa?
I got 29.
29. So y equals 29. All right. What did you do to both sides?
So I added 4.
What? Wait. Added 4? You mean like this? That's weird. I thought there was already addition going on. So I thought you had to subtract. Well, there's two ways of thinking it. Well, first of all, who got y equals 29? Okay, it's a tough one. This is what you have to do. You have to think of this, and they're going to get progressively harder. This is not the toughest one. All right. I want to end up getting y by itself. So if you're saying, oh, it's adding with -4, what undoes adding of -4? You can put it in two ways. You can do, Caroline?
Subtracting positive. Wait, no.
It's hard to say. It's very hard to say. Trust me, it's very difficult. But what's one way?
Subtracting positive 4 or 4? No.
You can subtract -4, which is also known as
4 positive.
adding 4. Subtracting -4 is the same thing as adding 4, isn't it?
Yeah.
What do you guys think? Subtracting -4 is the same thing as adding 4. And this is how you can confirm it. What's -4 plus 4?
8, 0.
0, which is what we wanted because we want y by itself, and then we get our 29. Okay? We'll talk more about those in a bit. All right, let's go back to page 125. Page 125 at the very bottom, I need you to get this down. Okay, write this, please. 8 minus -2. Okay, write 8 minus -2. I need you to convert that to an addition problem. Go ahead, write that down. Blah, blah, blah. So how do I convert this into an addition problem? And then I'll ask you how you did that. Okay, Jack, what's
8 plus positive 2.
8 plus 2, right? Or 8 plus positive 2? How many of you got 8 plus 2 there? Wait, you mean subtracting a negative is the same thing as adding a positive? And that's exactly what I'm saying. All right, do you guys remember what we called it? So this process from going here to here is called, oops, not that. It's called stay, change, opposites. Where's stay, change, flip at?
Fractions.
Fractions. Okay, so that's with dividing fractions. This is when changing addition. Wow. Huge. Anyway, thank you. That's how you go through that process. And the reason that happens is because when you're subtracting a number, you can really add its additive inverse. You guys remember your prerequisites? You remember those problems that say, find the additive inverse. What's another name for additive inverse?
Opposite.
Opposites. That's all it means, okay? That's how we tie those prereqs. Okay. Let's look at example number 4. Let's get a couple more easy ones, and then we'll get to those difficult ones. So example 4. C plus 8 equals 12. C plus 8 equals 12. I'm not impressed if you can figure this out in your head. It really isn't impressive. You should be able to do it in your head. What's going to impress me is if you can show it to me algebraically. That's impressive. Because you have to think of it a different way. 3rd and 4th graders, they look at that and they're like, I can figure it out in my head. Great. Good job, 3rd and 4th graders. If you're bragging about doing these in your head, you're a couple years late, a few years late. What I want you to be able to show me is that you can do it algebraically. That is impressive to me. So, who wants to do it? Callie, what do I do?
Okay, so you're going to subtract 8 from both sides.
Very good. Subtract 8 from both sides.
Then you'll get C there, and then on the other side you'll get 4.
That's impressive.
Wow.
Because if you try to tell a 3rd and 4th grader that, they're going to be like, what? What did you just do? I don't get it. That's algebra. That's like 3 years from now. For you guys, this is what's going to impress me. You think they stay this easy?
No.
Ask the 8th graders. They'll tell you if it stays that easy. Okay. So do you guys understand what I mean by showing work? I hope it's not too hard. Okay, example number 5. I'm going to tie in everything you have to do on these problems because they do ask you to do something else. Solve y minus 24 equals 16. Y minus 24 equals 16. All right, somebody read me the instructions on example 5. Read the bold type instructions there. Yeah. Sophie?
Okay. Graph the solution on a number line.
Okay. You're going to have to solve. It says solve this equation and then graph the solution on a number line. And I'll make it very easy for you to do that. But let's solve this first. What do I have to do to solve for y? Jack.
Oh, well, okay. You have to add 24.
Two.
24 and 16.
Good. Add it to both sides. What are you left with on the left side? Y. Because negative 24 plus 24 cancels itself out. What's 16 plus 24? 40. Okay, this is part of your answer. What did the second part say to do? Graph it on a number line. What? On a number line? Yes. Watch what you have to do. Please listen carefully. You draw a little number line, and in the middle, you're going to draw your number that you got for your answer. And all I require is a number after and a number before. Just one integer before and after. That's it. But how do I show that my answer on the number line is y equals 40? This is not enough. Is it 39, 40, or 41? I don't know. You got to do this. Caroline?
Put a dot on the line.
Where?
On the 40.
Right here, you got to put a closed circle and you're done. That's all you have to do. Look at their number line on example 5. They drew you this long number line just to show you 40. You don't have to do that. Just give me the number, one integer before and after. Or sorry, before and after. Yes, ma'am?
Why did you add them together and not subtract?
Which one? On this side, on the right?
Yeah.
So here, do you see we added 24 to both sides? So it's positive 16 plus positive 24. So they both have the same sign, and they're being added. So you just add like normally. 16 plus 24 is 40.
And how come you didn't do 24 and 16 and then 16 and 16?
Okay, how about this? You see this equation? This is called the left side. This is called the right side. So do you see adding 24 is the right first step? You see that? So I have to add 24 to this left side and 24 to the right side.
Oh, so you always do the one on the left.
Almost always, but on that last problem, I think it was up here. Here you had to add what was on the right side, so it depends. Sometimes again, but what you do is this: always look at the variable, find out what's happening to that variable, and then you can add, subtract on these problems. Callie.
So do you decide like that has a variable on it?
That's the side you're looking at to know whether add, subtract, multiply. So here, good question, guys. Very good questions. On this equation, I don't want to subtract 16 from both sides. I am allowed to do it. I'm going to get 0 equals, and then I subtract 8. Oh, no. I'm going to get negative 8 plus y. That's not going to help me out. So I need to do the same thing to both sides. And subtract 16 would give me y minus 40 equals 0. That doesn't help me out. So I got to do it from the side with the variable. Do it from the side with the variable. Okay. You guys want a tough one?
Yeah.
Last one here. If you could do this, you could do all of them. Number 9 on page 127, and then I'll write your homework on the board. On this one, you need to solve and put your answer on a number line for number 9. And when you get done with this, you can start your homework on another piece of paper. Then we'll go over this answer together. All right, I'll give you about another 30 seconds, but there's your homework. That's due tomorrow. You can start working on that. Yes, it's on that top rack on the far right side. Okay, what's your answer for number 9? Somebody. Emma Grace. 43. Very close. This is a tough one. It's hard because of how it's stated, but you can make it clearer. Michael.
27.
Close still. Tristan.
37.
M equals 37. M equals 37. What? Maybe you're thinking like, what? Are you sure? Okay, ready, guys? Listen up. Listen up. If you didn't get it, you probably need to pay attention because you're going to see a couple of these. I don't like dealing with this. I really don't. I don't like m minus negative 3. Can I rewrite this before I even start adding and subtracting from both sides? Can you do this? Can you do m plus 3 equals 40? And if I can do that, then what do I add or subtract from both sides?
40. No.
3.
Well, look at the variable. What's happening to the variable? It's being added with 3. So what should I do? Minus 3. Subtracting 3. And that's how you get that one. So change it to addition if it's really complicated subtraction. Do you see how I got to this step?
Yeah, I got that stuff.
Okay. What do I do to both sides to get m by itself? Or how do I get rid of this plus 3? I should.
I thought it was just that was and then you did and then you would positive 3.
No, you should. I see. No. This is not the answer right here. Like, this is not m equals 3 plus 40. You still have to get m by itself. And that means getting rid of this positive 3 by subtracting 3 from both sides. Questions on that one? Okay, it's going to be on you now. 14 to 33, and that's due tomorrow. If you need more practice on IXL, they have that. Solving one-step equations using addition and subtraction.